Good morning, my YouTube viewers. It is Crystal here, and what I wanted to do is I wanted to make a video about how you can make your own agent in Python. And obviously this is a very simple agent. It's not on the scale of the agents that you can create with ChatGPT and Copilot, but I still wanted to make an agent. The reason for this is because I was visiting my boyfriend's mother for a week, and for 5 days, and I decided that the best thing for me to do with my time was to learn about agents. So I went studying agents and things, but I wasn't really able to do it on my boyfriend's computer, and the reason why is because he had a Chromebook, and so I could go onto OneDrive and access Excel through OneDrive, but I couldn't access it through my own computer. So I decided that I'd make a very simple little agent in Python, and then in this simple little agent in Python, what it's going to do is going to analyze waste. So that's what we're going to do in this video that I'm making. So an agent is an autonomous, goal-driven software entity that can plan, reason, and take actions across different stages of the workflow. So this is a very simple agent that we're making. So if you want to know how to make a simple agent to give you a good beginner's introduction, then this is a good introduction. And we're creating this agent to analyze a waste CSV file. So what I did was I took an Excel spreadsheet and I converted it to a CSV file, and then I moved the CSV file into the drive of Google Colab, and that's basically how I did it. So in Python, the first thing that you want to do is you want to import pandas, which is a library that enables you to process your data. And then you're going to import matplotlib.python-splt, which is a library that helps you to visualize your data. And then so what we're going to do is we're going to create a class called Waste Analysis Agent. So we're going to define the init, which is the self, and it's going to accept the self and the file path as input. So self.file path equals file path. Self.df equals none. Now we're going to create a function within this class called load data, and it's going to accept self. So self.df equals pd.readcsv bracket self.filepath, and you're going to print data successfully loaded. Then we're going to create another function called def clean data, which accepts the self. So you're going to standardize the column names, and then what you're going to do is you're going to take the columns and you convert them to lower space, and then you're going to take the spaces and you're going to put an underscore in place of the space. Then you're going to convert the date to date time. Self.df brackets date equals pd.to-date time bracket self.df date, comma, errors equals coerce. You're going to handle missing values, but there were not any missing values in that CSV file. Self.df.fill equals size container unknown, in place equals true, and then you're going to print data claimed. Okay, now what you're going to do is you're going to create a function called analyze summary cell. So you're going to print summary by waste type, and then type summary equals self.df.group by type of waste, and then brackets weight tons, comma, cost dot sum, and then you're going to print type summary. and then you're going to print summary by location. So location equals self.df.group by brackets location, square brackets, weight tons, comma, cost dot sum, and then you're going to print your summary location. Now you've got a function called detect anomalies. So it's print anomaly detection, self.df, square brackets, cost per ton equals self.dx, square brackets, cost divided by self.dx, square brackets, weight tons. And high cost equals self.df, square brackets, self.df, cost per ton, self.df, cost per ton dot mean times 1.5. If not, high cost dot empty, print high cost per ton detected, print high cost, square brackets, type of waste, comma, location, comma, cost per ton. Else, print no significant anomalies. Now we're going to create a function to plot the chart types, and we're going to use Matplotlib to do that. Self.df.groupby, brackets, type of waste, square brackets, weight tons dot sum dot plot, brackets, kind equals bar, comma, title equals total waste by waste type, plt dot white label weight tons plt dot show. Now we're going to do costs by waste type, self.df.groupby, brackets, type of waste, square brackets, cost dot sum, brackets, dot plot, brackets, kind equals bar, comma, title equals total waste by total cost by waste type, color equals orange, plt.show. Now we're going to create a function called recommendations that it accepts self as an input, print recommendations, and then we're going to identify the most expensive waste type. Expensive type equals self.df.groupby, brackets, type of waste, square brackets, cost.sum dot idx maths. Print focus on reducing expensive type waste as it is in the highest cost. And then example suggests recycling if domestic waste is high. If domestic and self.df, square brackets, type of waste dot values, print consider increasing recycling for domestic waste to reduced costs. And then so now we're going to call up the class and the functions. So agent equals waste analysis agent, and then we've got the path of the CSV file that I created. So you've got agent.load data, agent.clean data, agent.summarize, analyze summary, agent.detect anomalies, agent.plot charts, agent.recommendations. And then so we've run this agent, data loaded successfully, data cleaned. You've got your summary time, your waste type. So you've got clinical waste at 9 tons at a cost of 6165, and you've got domestic waste of 4.45 tons, 1800. You've got summary by location. So you've got locations of Bracknell, Reading, the University, and Windsor, and you've got the weights, tons, and the cost. And then you've got your anomaly detection, type of waste, location, cost per ton. And then so we've detected our anomalies of clinical of Reading. Okay, so now what we've got is we've got total waste by waste type. We've created a bar chart. And then so in this total waste by waste type, you can see that there is almost twice as much clinical waste as there is domestic waste. So now we've got, just bring this down. Now we've got total waste by waste type, total cost by waste type. So you can see that to dispose the clinical waste, it's a lot more expensive than it is to dispose of domestic waste, because they have to take more precautions when they're disposing of clinical waste. And then we've got recommendations. Focus on reducing clinical waste. It has the highest cost. Considering increasing recycling for domestic waste to reduce costs. So this is your agent. It's a very simple agent that we created in Python just to give you an idea of how to make agents, because now that's the new buzzword, is creating agents, and agents are a lot more complicated than this, but this is just a simple agent to give you an idea of how to make an agent. And then as you become more proficient in agents, you might want to use like different software to create an agent. But sometimes you have to subscribe to the software, and then you also have to learn how to use the software as well. And since I already know how to program in Python and I know how to use Google Colab, I decided that the best thing to do in this instance was to write an agent in Python. This is a very simple agent, and I will try to become more proficient at making agents using other software packages as time goes on. So thank you so much for watching my video. If you like my video, please like and subscribe. And I'm going to be making some more videos about agents for you soon.